To generalize from the example that we saw in the previous video, we will now summarize the steps that have to take place in an RPC interaction between a client and a server. The first step, a server binding occurs. Here, the client finds and discovers the server that supports the desired functionality and that it will need to connect to. For connection-oriented protocols like TCP/IP that require that a connection be established between the client and the server process, that connection will actually be established in this step. Then the client makes the actual remote procedure call. This results in a call into the user stub, and at that point, the rest of the client code will block. Next, the client stub will create a data buffer, and it will populate it with the values of the arguments that are passed to the procedure call. We call this process marshalling the arguments. The arguments may be located at arbitrary, non-contiguous locations in the client address space, but the RPC runtime will need to send a contiguous buffer to the sockets for transmission. So the marshalling process will take care of this, and it will place all the arguments into a buffer that will be passed to the sockets. Once the buffer is available, the RPC runtime will send the message. And the sending will involve whatever transmission protocol that both sides have agreed upon during the binding process. This may be TCP, UDP, or even shared memory-based IPC if the client and the server are on the same machine. When the data is transferred onto the server machine, it's received by the RPC runtime, and all of the necessary checks are performed to determine what is the correct server stub that this message needs to be passed to. And in addition, it's possible to include certain access control checks at this particular step. The server stub will unmarshal the data. Unmarshalling is clearly the reverse of marshalling. So this will take the byte stream that's coming from the received buffers. It will extract the arguments, and it will create whatever data structures are needed to hold the values of those arguments. Once the arguments are allocated and set to the appropriate values, the actual procedure call can be made. This calls the implementation of the procedure that's part of the server process. The server will compute the result of the operation, or potentially it will conclude that there is some kind of error message that needs to be returned. The result will be passed to the server-side stub, and it will follow a similar reverse path in order to be returned back to the client. One more step is needed for all of this to work. Here we have as the 0th initial step that the client will need to find or discover the server so that it can bind with it. But before that can happen, somehow the server needs to do something so that it can be found. The server will need to announce to the rest of the world what is the procedure that it knows how to perform, what are the argument types that are required for that procedure, what is its location, the IP address, the port number, any information that's necessary for that server to be discovered and so that somebody can bind with it. So what that means is that the server also executes some registration step when this operation happens.